Good morning to all. Myself, Dr. P. Janagaratnam, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology. In my previous video series, I already discussed about the different types of robotic system and other types of CNC machines and all I already discussed. Today, I am going to discuss about the new topic which is related to the electrical discharge machining manufacturing process. Once we have to completed the design and design means we have to converted in our design into manufacturing process. So this is one of the unconventional machining process. CNC means computer numerical control and electrical discharge machining. How we are do the machining process by using the electrical discharge machining and all today I am going to discuss. So this is the general introduction regarding the wire electrical discharge machining. It is also called known as spark machining, spark eroding, burning, die sinking or wire aeration. It is a manufacturing process whereby a decided shape is obtained by using the electrical discharge. We have to produce the electrical spark between the tool and workpiece, and material is removed from the workpiece by a series of rapidly recurring the current discharge between the two electrodes, which means the in between the tool and workpiece. One of the electrode which is tool electrode and another one is for workpiece work electrode. So workpiece electrode, as a distance between these two electrode is reduced, the current intensity becomes greater than the strength of the dielectric. So this is the general wire electrical discharge machining process, which means the electrical discharge machining process. It is a conventional machining process. In our manufacturing technology and all, we have to studied about the conventional machining process. So in our conventional machining process, there is a direct physical contact between tool and workpiece. In our unconventional machining process, there is no physical contact between these tool and workpiece. So this is we have to give the power supply, and this is the servo control which the positive terminal which is connected to the tool and negative terminal which is connected to the workpiece. So the entire setup is fixed in between this dielectric fluid medium. Why we have to use this kind of dielectric fluid medium means it can reduce the heat generation during the machining process. So this is the tank. So this is the EDM setup. So this is the EDM components. Here we have to use the dielectric and flushing mode, which will be remove the some of the machined components are inside in the tank will be removed by using this kind of flushing, and workpiece holding device and power supply. And majorly we have to focus on the three components like input parameters, pulse on time, pulse off time, and voltage. These three all are the important three input parameters while we have to consider the machining process. And what are the output parameters we have to consider means we have to consider as the material removal rate, the amount volume of material removed per unit time, and we have to consider the next one is for surface roughness. We have to reduce the surface roughness means automatically we have to increase the surface finish of machined component. So this is the main components of electrical discharge machining: electrical power supply, dielectric medium, workpiece, tool, and servo control unit. Those servo control unit which will be used to maintain the constant gap between these tool and workpiece. So this is the general electrical discharge machining working principle. It is a process of metal removal based on the principle of material removal by an interpreted electrical spark discharge between the tool and workpiece. In EDM, a potential difference is applied between the tool and workpiece. Both tool and work materials are to be conductors. So the tool and work materials are immersed in a dielectric fluid medium, which will avoid the heat generation during the machining process. Generally, we have to use the deionized water dielectric medium and kerosene used as an a dielectric medium. A gap is maintained between the tool and workpiece, and depending upon the applied potential difference, we have to vary the our power supply from 50 to 450 voltage. Generally tool, the negative terminal which is connected to the tool and the positive terminal which will be connected to the workpiece. Wherever we have to remove the material, that will be connected to the positive terminal which will be connected to the workpiece. So with the level of the potential difference like plasma channel collapse and create compression shock waves, high spot and workpiece surface, and these are all the some of the working principle. While we have to consider as an manufacturing process, these are all the some of the assessment questions. Which of the following shapes can be produced using the electrode discharge machining? Means we have to make the complex shapes. State whether the following statement is true or false regarding the applications of EDM. It advanced machining process, the incorporations of EDM with the SIM increased the length of the time of unit operation, which is false. We have to reduce the timing. And what are the values of general feed rates using the drilling in the EDM process? Means we have to select 0.1 mm per minute. So this is the general assessment questions. And which type of electrode is used to drilling the electrode discharge machining? Means tubular electrode. When you compare to the conventional machining process, which will be increase the MRR, means twice it can be increased. Which of the following are the applications of electrical discharge machining? Means all the mentions. We have to make the holes, slots, texturing, and all kind of machine manufacturing process will be done by using this kind of wire electrical discharge machining. So this is the general introduction and working principle of the electrical discharge machining. In our next class, we have to discuss about the one more manufacturing process are used in our CADA subject. Thank you.